In this series of videos, we are going to talk about the drop shape analyzer, which is mainly used for interfacial tension and contact angle measurements. So our system consists of three parts: the DSA unit itself, which has the visual controls; the cell, the high pressure, high temperature cell, which is separate from the DSA; and finally the computer, which has the software. The DSA unit has the camera, which is a magnet clip-on that goes through here. Please be very careful with this camera. If you are manipulating or not actively doing an experiment, remove the camera and put it inside the drawer. We have the zoom and focus controls, the tilt for the camera, and the power button for the system, which is at the back. The light switch is over here. And again, as I said, this is independent from the cell. You can work with this system alone without using the high pressure, high temperature cell, but use it for convenience for all experiments. For the high pressure, high temperature cell, we have the body of the cell itself, which is located here. These are the connections that we will go through in details when we start doing the experiments. We have the see-through windows attached to the right and the left of the system. The one on the right is labeled R. Please keep them for the same labels. The valves and controls also, again, we go through all of them during the experiment. This unit is for the temperature control. So, for example, right now it says set is 25 and ACT, which is the actual, is 26. Unfortunately, this system doesn't have a cooling mechanism, so whatever the room temperature is, will be the lowest temperature that you can get. Also, just to make sure that you have the correct temperature, we have this thermocouple, which is attached to the cell itself. We get the most accurate reading of the cell from this device, which is 24.3 in our case here. The software of the system can be found on the computer, which is this logo, the A, Advance. We open it. It takes some time to load. So this is the home menu. We basically use only two methods, which is either the pendant drop or the Cecil drop. The pendant drop is for surface tension and interfacial tension, and the Cecil drop is for contact angle measurement. If we go to the pendant drop, we choose it. We come here, choose this template, and then click Create New. We get the interface, the user interface. These are the details of the measurement itself. This is where the visual output comes from the DSA system. But once we put the camera, we'll be able to see. So right now, this is the cell, which needs a bit of adjustment in order to center it. And these are the different controls that, again, we will go through once we start our measurement. We will demonstrate the interfacial tension measurements between DI water and air, which is also an indicator of the cleanliness of the system. It should be around 72 millinewton per meter. So, in order to do that, we have this unit right here, which is the fluid dispenser. We put the liquid, which will be DI water, inside this small cell. Then we will be closing this valve, which connects the dispenser to the cell. Then we will open this valve, suck the liquid inside the dispenser through rotating, and then after it is fully retracted, we close the cell, the valve between the cell and the dispenser, and then open the valve between the dispenser and the cell in order to discharge the liquid towards the cell itself. Before we start our measurement, this is the needle that we use for dispensing the fluid inside the cell. Very important is we need to get the outer diameter of the tip of the needle, which we are going to use to calibrate the software with. For that, we have this caliper, which we use to get the outer diameter of the needle, as I mentioned. I measured it beforehand. It was 0.961 millimeters for this particular needle. Of course, sometimes we use another needle, so it's always better to get the measurement of the needle before doing your experiment. So here, this is the dispenser for the liquid that's going to be displaced through the needle inside the cell. This cell here is where we put, or the reservoir is where we put our liquid. We make sure that this valve is closed, which is the connection between the dispenser and the cell. We open this valve between the reservoir and the dispenser. We suck the fluid in by retracting the cylinder. Then we close this valve and open this one. So we close A and we open B. A is between the reservoir and the dispenser, and B is between the dispenser and the cell itself. So we open B and then we discharge our liquid into the cell through the needle. So the needle can be placed either through the top, which is this manifold, or through the bottom, which is this one. This one is a stop plug, which can be placed either on the bottom when we are using the top for the needle, or we can place it on the top when we use the bottom for the needle. And this is the needle after, of course, we took the measurement of the outer diameter with the caliper. We carefully place it inside and we screw it in. Then we take the connecting line, which goes to valve number B. All these roll valves use a number 10 key. We don't tighten them too much. And this bolt here uses a 3/4 key, 3/4. So, of course, this is the glass window on the left-hand side of the system. It consists of the screw bolt and the see-through glass itself. Notice that the camera is not here right now, since I'm still modifying and setting up the system. We do not want to break the camera. So now that our cell is ready, we get our camera and we place it here. It's simple clip-on, magnetic. And now our system is ready. We can come to our software and we can see that the needle is visible, but we still need to center the cell itself. So after we center the cell, which is by basically moving the DSA system itself, we can raise or lower the cell using this dial, as we can see here. The cell is going up and the needle is coming down. Still, the needle is not completely centered. So this looks good. Now we are ready to calibrate the needle. So we come to this button, you click it, you set the mode to manual, and you will see that the software tries to capture this, the needle. We have to place it on either side of it, and we put our object size, which is in millimeters, which, as I mentioned, was 0.961 for this particular needle. The tilt angle, we want it to be 0. So in order to calibrate our system, we come to this button. We have either the manual option or the automatic option. It's better to use the manual option since you can control the exact location of your settings. So we have to go to the left hand side and to the right hand side and to the exact bottom of the needle. We have the object size, which is the width of the needle, which is 0.961 millimeters, and then we click calibrate. Here we just put the name of our measurement, which will be DI water air IFT. You can write the details if you need. The temperature, as we saw it was 24.6 degrees C. This is a manual syringe. The substance so under configuring those, we have to put the properties of the two fluids that we have. So the manual syringe is the liquid that's going to come out of the needle, which in our case is DI water. We can just click here and look for water. As for the surrounding phase, it is air. Of course, if you want to do it on your own, you do not trust the values that are already preset, or you know for a fact that your properties are different, you can always do the custom. You put the name and you put the density. But since the values are already preset, we are just going to use them. So this is ready now. Now we load the water inside the system. So we have our DI water, which goes inside the small reservoir here. Make sure that this valve is closed, which is again valve number 8. We put our water. Not all the way to the top. So now the water is inside here. We go to valve B and make sure that it is closed. We open valve A and we start to suck the water inside the dispenser by rotating it counterclockwise. Now it reached the end. We close valve A and we open valve B. Now, once I start dispensing the liquid, it should go through the line all the way to the needle, and then you will be able to see it on the software. So I'm turning the dispenser clockwise, and the water should go through the line, and now we can see it inside the software. We can see that there are some impurities, which means that the cell is not clean, that the lines were not clean, so we can flush it for a bit. Now, after flushing it for several times, you can't see any more impurities inside the liquid, which is good. So now comes the tricky part, which is trying to keep the droplet attached to the needle. So we try to grow it by injecting the liquid inside very carefully. This line, which is called select area, has to be exactly at the bottom of the needle. And the B factor here is an indication of the quality of the droplet, of the shape itself. We usually want it to be on the green side, which depends on the fluid system. And here you can also see the volume of the liquid droplet that you have. Unfortunately, the system is very sensitive to vibrations, so always try to keep the surrounding area around it quiet and calm. The droplet keeps getting smaller, which is maybe an indication of that there are some air bubbles inside the line. So we can just try to dispense a few more droplets. So once the droplet size does not change anymore visually, we can come to the automation program, click on New, Action, Single Measurement, Load is repeat number of times or repeat until. You can determine which one you want. Good one, for example, if you wanted to run for a specific amount of time, you go for repeat until. Or if you want a set number of data points, you get to repeat number of times. And this is how many times you want it to be repeated. It depends again on the experiment itself. For now, let's say it's 1,000. And the interval between every two data points, let's say it's 3 seconds. Once we are ready to start the measurement, we come down here to the Start Automation and we click Run. we click on the arrow, we see that these are the data points being captured, and this is the visual representation as a graph. We usually wait until it stabilizes and to get our exact value. Let's wait for a bit. So we left it for a while, but as we can see, it's not stable at all, which indicates that the system itself is not clean. So for cleaning, we use loads of DI water and isopropanol, and in case of oil, we use, of course, toluene. So we just keep flushing the system, and then at the end, again, after we finish cleaning, we test it with DI water to make sure that it's 72. So right now it keeps fluctuating between 63 and 240 something. So there's something wrong inside the cell. But this is the process of how the IFT measurement should be done. And in an optimal case, you would get a somewhat straight line after the system stabilizes, and you get the accurate reading for your droplet. So in order to stop recording, we can either pause it using this one, which is pause automation, or we can just stop it completely and say stop. Now the data is recorded. You can come here to the save measurement and find hours, which is DI water here. And then we can export it or save it. There are many different options for the data acquisition. We can export it using Excel format or the original data file, which can be again later loaded to this software, and then you can modify and see the different graphs and plots. So in case we want to fill the cell and have the surrounding phase with a gas that is not air, for example CO2 or nitrogen or whatever, we have the cylinders placed all the way over there and connected to the cell through the line, which comes here. We have this valve, which goes all the way into the system through here. Then we have the gas inlet valve right here, which allows the gas to pass through the line inside the cell. And if we want to purge the cell from the gas inside, we just open this valve where the gas will come out through this line. Unfortunately, there is no pressure control unit in this system, so if we want to achieve a certain pressure, it's better to get it directly from the cylinder, and it's better to go above the pressure that you want, and then you can purge the cell delicately until you get the exact value that you want. We will demonstrate now. I will let the gas from the cylinder inside the cell, and we can see how we can adjust our pressure. So I let the gas flow into the line from the cylinder. Now I come to this valve. This valve right here, open it to let the gas flow to the system. To make sure that the purge valve is closed, and then we open the gas inlet valve, and we see that we open the gas inlet valve and the pressure went up to 100 psi. We can keep doing this process until we achieve the pressure that we want. So we'll close the inlet valve. we let more gas in from the cylinder. We open this one, and then we open the gas inlet again. It went a bit more above 100. So you can keep doing that until you reach the level that you want. If it shoots above, and for example you want to have exactly 100 psi, we come to the purge cell and we open it very carefully to let some of the gas out. You can hear the gas coming out from the line. Once it reaches 100 psi, we close it. So now we have 100 psi of the gas inside the cell. Of course, it's better to first purge the cell multiple times to make sure that there is no more air inside and that there is just the gas that you want. If you are using a gas such as methane or anything that's dangerous, please always place the fume hood close to the system itself so that it can suck out any gas that's coming out. So now we want to purge the cell completely. Let's say we already filled our cell, the system is ready, we did our interfacial tension measurement, and now we want to disassemble the cell. So first we purge the cell from the gas to release any pressure that's inside. So we just open the valve. Again, carefully, we don't want it to expand rapidly. Make sure that the fume suction system is as close to the system as possible. Once there is no more gas inside, just open it a bit more, and that's it. So now we know how to place a different gas inside the cell and how to purge it. In case we want to do a submerged measurement, for example, one liquid inside another, like cold water inside oil or oil inside water, we first have to flood the cell itself with the liquid. To do that, we place our surrounding liquid inside this cell here. We first close this valve, we place our liquid here. Then we open this valve and there is another valve here labeled H2, it's the top one. Make sure that this one is closed and then rotate the cylinder in order to suck the liquid from the liquid cell to the dispenser. Once you fully retract it, close this valve and then open H2, which is again the top one, and dispense the liquid which will go through the line into the cell. So this is the valve, this is H2. The bottom one is H1, which is for discharge. If you have excess liquid and you want to discharge it, not inside the cell but to the outside, you use H1. And the line, it goes all the way to this part right here, and then it goes up into the cell. We also use this method in order to clean the piston and to purge the system all the way to the cell from any liquid that's inside. This system is used with high salinity solutions and oils, so it needs to be very thoroughly cleaned. It's most probably the most difficult part of dealing with the system, not taking the measurements but the cleaning. You have to be very thorough with it and very patient because it takes a lot of time. So just keep loading your cleaning liquid, whether it's DI water, isopropanol, or toluene. Use the proper valves to suck it in, and then flow it right to the cell. Always use a petri dish, which is placed below the cell itself, in order to collect anything and not make a mess of the liquid or let it seep through. So now that we know how to do the interfacial tension and how to clean the system, we want to demonstrate how to do the contact angle measurements. First, after of course the system is cleaned and everything is ready, we open our cell. So the water that's coming out, of course, is from the one that we used during the IFT measurement. In order to do the contact angle measurement, we use this holder right here, which is used for the Cecil drop if the droplet is coming from the top to the bottom. So our disc will be placed on top of the holder, and then our droplet comes on top of that one. So for example, if we have a rock water air system, the rock will be placed and then the water droplet will come on top of it. If, for example, we want to do a water rock oil system, we use this holder right here. It has a slot where the needle comes from the bottom. Our rock disc will be placed on top, and the oil droplet will come from the bottom to reach the disc itself. So we will demonstrate on a droplet that's coming from the top. So we have our holder, we place it inside the cell. Try your best to make it as horizontal as possible. Right now I don't have a rock disc sample, so I'm going to use a glass disc, which is the cover from a microscope slide, and carefully place it on top of your holder. Make sure that it is directly under the needles, because we want the droplet to fall onto the disc or your rock sample. And then again, try to make it horizontal, because you don't want any discrepancy in the contact angle measurement. So in order to confirm whether it's good or not, we can place our camera and we can check it visually on the software. So after opening the software, we come to the Cecil drop, which shows the template, and we click create. You see it's zoomed in, so we can use the zoom function to zoom out. And we can use the dial to lift the cell in order for us to be able to see our rock disc. Of course, if there is a rock disc, it would be much thicker and more prominent than that. This is glass, so it's somehow visible. But a rock disc will be a black thick line at the bottom here. It will be more prominent. But for the sake of the demonstration, we will use this one. So we can see that it is horizontal, so we are good. We can place the window and start our experiment. So after placing the window, we can adjust the DSA system in order to try to synchronize the picture. Now, in this case, we have to be very careful, so it's better to dispense as much of your liquid and make sure that the lines have no gas bubbles inside before you place your droplet onto the disc. Because once you get a droplet, it might ruin your system depending on your experiment, and you would have to redo it again. So be very careful to get exactly one droplet onto your disc, and then we can start our experiment. For the calibration in the Cecil drop case, we come again to the same button. We go down, and typically you want to do it to your disc. Since you know the exact dimensions of your disc, you can just put it to the boundaries and then put your value inside. In my case, I think it was 50 millimeters. And then we say calibrate. So now the system is calibrated. We can inject our liquid droplet to fall onto the disc. Of course, we also have to put the name, the details, and the surrounding phase, which again in this case is air, and our liquid phase, which is water, in our case here. Once the software is ready, we carefully start dispensing our liquid. We need to be very careful in order to get just one droplet onto our disc. Now we can see this means that the disc is actually not directly under the needle, so the water is just seeping down. So we made a mistake by placing our disc. So I opened the cell, I tried to centralize the disc again, and of course since we made changes, we need to do the calibration again. Try to dispense droplet very carefully. Okay, so we obtained our droplet, and now the system is starting to stabilize and trying to get the contact angle, as we can see here. So we come, we choose a single measurement. Let's say repeat a number of times. Let's say 100 times, and for an interval of 3 seconds. We choose the manual syringe to be water and surrounding phase to be air. Temperature is 24.6, and here we have water, air, glass contact angle, and finally we can click start. We go down, the system will start capturing the data, and we will see the graph. Of course, it will go up and down until it stabilizes. We wait until either the measurements are done or until you see that there is no more significant change and you got a good value for your measurement. In order to set the temperature for a high temperature experiment, you come, click down, enter set temperature, click enter. You choose the temperature that you want. For example, let's say it's 35 degrees centigrade. You click enter again, and that's it. You click escape and escape. Now the set temperature is 35, the actual is 26, and it will start to go up, 27. So sometimes it overshoots, but then you have to just give it time for it to cool down. And we can make sure using our thermocouple of what the exact temperature is. So it is still rising. 26.5, 26.6. So it's always better to depend on this external thermocouple in order to get the exact temperature that's inside the cell. If you are finished with the experiment and we want to let it cool down, we come again, bottom arrow, enter, reduce the temperature to something like 25 or 20. It will go down as low as the room temperature, as I said, since there is no cooling mechanism. And you just click enter and escape. So of course it will lose heat much more slowly. If it's not too hot, you can open the cell itself, but if it's high temperatures, 40 for example or above, it's better to wait until it cools down before you start engaging with the cell. And again, please always remember to remove the camera before manipulating or changing anything. Just put it if you want to check the visuals on the software or if you're actively doing the experiment. Other than that, always remove it and keep it inside the drawer. So right now it's constant at 32.2, so it will take time now to cool down. After we finish our experiment and everything is done, cleaning is very important. So we flush the lines all the way to the cell using this one by opening this valve, closing this one, sucking the liquid in, then closing this one, opening this one, and injecting the liquid all the way to the cell. Do it several times until we are sure that there is no more of our original liquid inside. So it's either water. So we first flush with water or toluene, depending on the solution that we were using. Then we clean with isopropanol, and finally we do it again with water.